What's up, everybody? Welcome to System Crafters. I'm David Wilson, and today we have another instance of our System Crafters Live Friday streams where we hang out with the System Crafters community and talk about topics of interest to everyone. Hopefully they'll be of interest to everyone. Let me get some things set up correctly here, because I think I've changed some stuff since the last time I streamed, and I can't hear myself as well. Just mess with some dials a little bit. How's everybody doing today? Bump the music a little bit. Okay. All right, let's say hello to the folks who have arrived so far. Luis, TRDV, F Society, Luis, Alejandro, Mark, Zed, Tomas, Yadira, or Yadia, Pavel, Ragu, Miljan, EC Gade, Garjola. Nice to see all the familiar faces here today. So this has been a very difficult couple of weeks because I think I probably mentioned last week, but my daughter's daycare was closed due to a COVID outbreak, and luckily we didn't get affected by that, but she's been home for 2 weeks, so it's been very difficult to have time to do all the normal things that I would do. So I did not get to do a video this week, unfortunately. I apologize for not having the video that I had promised in the Emacs Essentials series, but I'm going to get that out next week. But as always, I want to do the live stream on Friday because it's a lot of fun, and because, you know, it's a good opportunity for us to hang out a little bit and chat about cool stuff. Lewis asks, could I please do a short overview of the Mesche project? I will certainly do that in just a moment. Hey, Mark, Ignacio, Experimentales Zug. Once again, I don't know how to pronounce that. Sirotin1, Herman, Joshal. Yes, I am a person with a child. Thanks, Antonio. Yes, we're doing well. And hi to you as well. Yeah, everything's good. Today's the first day that my daughter's back at school, so it's nice to be able to have a full day of work again, because I've been working half days the last 2 weeks, and that's not been very easy. And pretty much all of my free time has been funneled into this Lisp Compiler project that we're going to talk about in a second. So that explains why I didn't get a video, because I've been kind of obsessed with what I've been working on, and I've been making a lot of progress. So hopefully today you'll see why I had less time to spend on video. Hi, Renan. All right, let's get started. So today I wanted to give you a brief progress update of the project that I talked about on the stream last week. It's a new, I guess you could call it a scheme-inspired systems programming language called Mesche, and I'm calling it Mesche because it's just the word scheme with the characters shifted by a couple of letters. It's a working title. We'll see if I change it later, but the idea is that I really enjoy programming in Lisp dialects, basically, especially Scheme. I like Scheme quite a lot. And I wanted the language that allowed me to do more low-level programming for things like game development, audio programming, application development, just low-level development in general. And typically with Lisp languages or Scheme implementations, you have a virtual machine-based implementation, or maybe it compiles a native, but it still uses garbage collection, and you don't really have as easy access to low-level stuff. That's not necessarily true across the board, because different implementations of Lisp or Scheme have different levels of, access to the low-level parts of the machine. But I wanted to do something sort of on my own and see how far I could get with it. So I basically started writing from the bottom up. I wanted to write a complete tool chain end to end, starting with the linker and the assembler, and then later getting on to the parts where I would develop the compiler of the language down to the assembler, and then that compiles the executable. And I've been having a lot of fun over the last week. I guess it's been a week. Writing the linker, or a basic linker, and a basic assembler. And I also started working on a disassembler because, well, I'll tell you why whenever I get to that. But it's been a lot of fun. I've learned a lot so far. I've also spent a lot of time scratching my head and reading a lot of documentation and books, trying to glean all of the necessary information to do this. So hopefully I can share with you some of that knowledge in case you're curious about this type of thing as well, so that you can save yourself some of the trouble that I had to go through. Hi, Ashraz. Ashra says, use package parenting, hooks, parenting, idle time, configure Emacs. Yeah, basically that. Luis says, in my language, mesh means to mess, as in don't mess with that. So good name. Yeah, it is like a mess. It could be a mess, or it could be for messing with things. So yeah, it sounds pretty good to me. All right, so basically, like I had mentioned before, I've been focusing on the linker and the assembler, and also trying to get basic program execution working. So don't get your expectations set too high, because it's very basic right now, but I did get something working, which is pretty fun. Let me jump into the code and I'll show you what I mean. Whoops. I need to fix my tab completion, because sometimes it just gets a little bit too overzealous and I'll tab into something that doesn't exist. All right, so I'm writing this whole project so far in Scheme. I'm using the Chibi Scheme implementation of Scheme, which is basically an implementation of Scheme that is meant to be embedded into a C program. It could also be used standalone, but mainly it's meant for embedding, for scripting C applications and whatnot. I'm using it because I'm able to compile it statically into a C program to make a standalone compiler that's written in Scheme, until later at some point when I'm able to compile the compiler with itself, which is something called bootstrapping, or self-hosting, I guess you could call it. I'm not going to be at that point for a while, so I have to use some other language to write this. So I've chosen to use Scheme because I enjoy writing Scheme, and because this language I'm making is inspired by Scheme, so it makes sense to use the language that I'm inspired by to think in terms of it, and then apply that to what I'm developing. So right now we're looking at the main file for the compiler. And what we really see here is just a couple function calls. One is to the assemble function, and I'm passing in a list of lists, basically. Typical thing that you see in Lisp programming. And one thing here is I'm defining a variable. This vars section here doesn't actually work right now. It's something I'm working on in a different branch. But the important part is that I have this code section for the code, the assembly code for my language. And I'm defining a symbol called start, which is the starting point of the application. And I also have a few instructions here that are written in something that looks like assembly. It's sort of a mix between GNU assembler and Intel assembly. I guess that's AT&T and Intel assembly, if you know what those are. But basically the idea is that you have a simplified representation of what the machine code would be, but it's written in a human-focused language that then gets turned into machine code. So the whole process of the assembler is to take these instructions that are written in this way and then convert those into the bytes that the machine can interpret and execute. Once I've run this through my assembler, I save it into a variable called main file, and then I run this link executable function on it. I tell it what the output file path is, and I also give it the list of object files, effectively, the compiled or the assembled files that are a part of the program. So in this case, this could be a number of files, but right now it's only just one, this main file that we have here. So the linker's job in this case is to take this list of files and then combine them all together into one program, and then do a lot of work to basically update all of the sections of that program to be aware of the fact that it's now part of a larger file. Because whenever you compile this code for this one file, it's very simple, because you just have like the list of instructions for that file, and you also have maybe some data that's necessary for that file. But the linker has to take those independent files and stitch them together into one larger binary, and then update all these memory addresses that might be referenced there, which is kind of a tedious thing to do. And I've got some ideas on how to do that, but I haven't started writing that yet. So this is really it for now. If we run this program, what's going to happen is it's going to take this assembly, turn it into machine code, and then create an executable out of it. So I'll show you how that works first, and then we'll go into the code that actually does the work. And I'm not really intending to like teach so much about what's going on here, more than just like give a report about what I've learned. I will do some videos some point in the future that goes more into detail about all this stuff. But for now, let's just say that we're all learning together. I think F Society is asking what Lisp does my kids use. They don't use any Lisp because my daughter is only 2.5 years old, so it's a little bit early for that. Okay, so I'm gonna run chibi scheme on the main file, and that's just gonna run this code straight out. So we'll press enter on that. A little bit of output here. I don't know why chibi gives me these warnings, because I don't know where it thinks I'm importing this twice. But that's okay. Also, I've got some output here. I think some part of my code is writing out the list of bytes that I'm going to be putting into the output executable. But we should be able to see that there is a test bin here inside of this output folder. It's about just a little bit, no, it's about 4K, like just a little bit over 4K. So very small executable. And it is an executable. It's marked with the executable bit. So I'm gonna try to run that really quickly, test bin. And here's the very underwhelming result of all this. In fact, before I do that, let me do this one really quickly. Echo, yeah. So I'm gonna echo the exit code of the previous program that was executed, because it's important for seeing what this demo does. Let me run this one more time. I'm looking at the chat, wondering why messages are being retracted. I'm hoping that YouTube isn't trying to block things. All right, so bin/test bin. I'm gonna run that, and there's no output, but that's intended because I can't really do much with the language in its current form just yet. But what I can do is set the exit code of the program before I exit. So I'm gonna echo the same exit code again. So if you don't know anything about bash, which I'm not using bash right now, I'm actually using eShell, but the same thing works here. This variable in bash or in eShell, the $? will give you the exit code of the last program that was executed. And typically an exit code is intended to convey information about whether the program failed, or maybe some code that indicates a particular result. In this case, I'm setting the exit code of the program to 42 in this assembly. So if we look at the assembly that I'm writing here, I'm moving the number 1 to the EAX register, and I'm moving the number 42 to the EBX register. And what's happening here is that I'm invoking a system call right now with this interrupt. So I'm making a system interrupt. I'm not going to go into explanation of what an interrupt is right now. But basically, it's a way to signal to the operating system that I want something to happen at the kernel level or at the system level. And it looks in these registers, these particular registers that are defined by the CPU. And the 1 basically means exit, and the 42 is the parameter I'm passing to exit, so like the exit code. So now that I told you about all this, basically what this means is that this program just sets the exit code and then tells the program to exit. So now, if I want to look at the exit code of the program that I just run, this test bin that I just created, I'll echo that, and then it says 42. So we can see that I was able to create an actual assembly, an actual binary that is capable of executing this system call to set the exit code and then exit. So let me see, do I have objdump installed here? Great. All right, so I can use objdump to look at the content of this binary. So you can see that there's actually machine code that's written in here. So objdump basically just takes the binary section or the text section of the program that you want to inspect, writes out all of the machine code for that, and then also gives you a disassembly view, basically tells you what the human readable instructions would be for that. So you can see that it effectively maps it back to what I put in, but it looks different because it's a different assembly language, basically. This is the GNU assembly language. So that seems to work. And I'm pretty happy at least to get to that point, because there was a lot of work that I had to do to even get there. The important thing about all of this was the writing of the linker itself. And what it does is it knows how to write out a program in the ELF format, which is the executable and linkable format, I believe is what it's called, which is the binary format on Linux, and maybe some other operating systems too, but the Linux primarily is what I know it from. So This format is the format that the operating system needs a binary to be in before it can read and execute it. And there's a specification for it. I sent a link to it, or I provided a link to it in the last stream. Basically, you just have to follow that spec and then write out a binary with all those sections of information with the machine code that you want to write, and also with any data that your program needs to execute. And then the OS should be able to load and run it and pass those machine code execution or instructions over to the CPU for it to run directly. So there's also the readelf. Let's see, do I have that program? Great. Readelf program will give you more information about it. So I can look at bin/test bin, and it will tell you information about all the sections of this file. And the way that I went about trying to make my linker work is I followed the specification for elf, and I tried to write out all the pieces that I could, that I understood how to write out up until that point. And then I used this readelf program to see if it was capable of reading back what I had written. I would also go take a simple assembly program and compile it to a binary, and then use readelf to look at that too, and compare my output with the output of a real program so that I could sort of tell what I'm missing. I learned a few things from that, especially around the idea of the program segments and the sections, which are, they sound like they're separate things, but actually they overlap in some cases. And that's something that you don't really know until you start looking at the output of a program compiled with an existing tool that knows how to do this already. So that was a big learning experience, I think over the weekend, basically. But in this case, we can see that I have one program header here. I have 3 section headers. And the readelf program will print out more of that information as you scroll down. I'm using the -a parameter to readelf to print out everything about the program that it can tell me. It tells me that I have a few section headers. One is the text section. So in an elf program, the text section, while it says text, actually it's code. I don't know why they call it text. There's probably some historical reason why it's called text, but this is a section that contains the actual machine code to be executed. It may be called text because you can also keep text in it as well. You can have strings in that section to be referenced, but I think typically you don't want to do that. It's better to keep those in a data section, and potentially even a read-only data section. Something we can talk about another time. Then there's also this this string table that has to be written out, which actually has the names of all the sections. So the elf file format is very self-referential in that when you write out sections of the file, there are going to be sections that refer to other sections, and they'll also provide metadata for other sections. So there's a lot of stuff that you have to put together before you can even start writing out any parts of this file. And it is a little bit confusing at first to figure out what order basically you have to write all this stuff out in to get all the data you need to fill in all of the sections of the file. So that was a little bit of a head scratcher in the beginning, trying to figure out how to do that effectively. But I eventually kind of cracked the code a little bit, and I've gotten to the point now where at least I can write out machine code into the file, have it execute correctly, and have a correctly formatted binary that can run just fine. So pretty happy with that. So let's see. Let's actually look at the linker itself. I'll look into the lib folder /mesh/linker.sld. And someone had asked last time what an SLD file is. That's basically a scheme library definition. So the newer specifications of scheme, I want to say maybe it was R6RS or R7RS, like the more recent versions of the scheme spec, have this library definition. And basically it allows you to create a module. So I'm making a module that I can import. This module is called Mesh Linker. And Chibi Scheme has a convention of having a lib folder with the subfolders being the names of the parts of the module path. So it's something you just have to follow as a convention so that it can load up as a module. Previously, Scheme did not have any kind of module format, so it was just loading in files directly. But it's nice that Scheme gained this functionality over time. So I've got some things that I've defined here, some constants basically for different sizes of things. Also the starting program start address, which is something that is not very obvious. You would read the elf header of a particular program and see that the start address was around this hex 400,000 value. And you're like, why is it that? Well, the ABI, the application binary interface for System V or Unix programs, says that it should be there. So I had to find a spec basically that says where that should be. I don't know why that's the case. Probably because it's the some boundary of the page size of the operating system. But we know where to start writing out the program, or actually this is the virtual memory location of the program. One thing you have to keep in mind with a linker is that there's a location for all these pieces in the actual file, but then there's also a location in virtual memory where these things should map to. So whenever your operating system launches a program, what happens is that it will create a process image, and then it will have virtual memory, which is not your real memory locations. It's actually a way that the OS maps real memory locations to the virtual memory of your process. And then you, as the programmer who's writing out your linked executable, decide where everything goes inside the virtual memory of that process. It's something you don't have to think about at all whenever you're writing C applications or any other higher level application, because the compiler takes care of that for you. But when you're writing your own compiler, you have to know all this stuff, and you also have to figure out where all these things come from. So this is definitely a spelunking journey, more than anything, I would say. I mean, there's not a really good end-to-end resource for how to do these things. You kind of have to figure it out yourself by piecing together a lot of info. So I've got a lot of functions for converting numbers to different byte arrays, basically, or byte lists. The reason why is because I have to convert a number to the Little Indian version of a byte array, effectively. So if I want to have the number, I don't know, 400,000, let's say. If I want to have the number 400,000, I have to take that number and then convert it into a string of bytes that is in reverse order, effectively, because this is Little Indian, where the least significant byte comes first rather than last. So they have to have some functions to convert that. Also some other functions for alignment, because apparently one thing you have to care about whenever you're writing out binaries in ELF format is that you have to align certain segments of the file with the page size of memory in the operating system, which is 4096 on Linux. So whenever you write out a piece of the file, you actually have to put padding up until that next boundary of 4096 and then write the next section, just so that a whole bunch of your code can be loaded in to memory at once in a way that's aligned correctly. There's all kinds of little details like this that are probably going over your head right now. They go over my head a little bit too, but it's interesting to learn it, to understand how everything goes from the bottom. Let me go look at the questions really quick, because there's some people talking here. Garjola says that his daughter was 2 years old when she knew C++. That's pretty impressive. I didn't know C++ until I was probably 13. Donald says, wonderful exploration and learning experience of ML, Lisp, and computer programming. Yeah, I'm hoping to expand a little bit into stuff like this, just to give some background on all the cool stuff that we use, like Emacs, etc. To learn the underlying aspects of all that, I think is pretty interesting. Let's see. Drishal says that he knew eLisp and Python when he was 7. Well, that's cool. Let's see. Pavel says, I knew Pascal when I was 7, or though I knew, to be exact, or knew of it. Yeah. The only language I knew whenever I was 7, which I didn't know very much about, was BASIC. The old BASIC. Let's see. Martin says, can we see bootstrapping your own language as follows? Write a compiler for Mesh in Chibi, write a compiler for Mesh in Mesh, compile compiler for Mesh with Chibi compiler, compile compiler for Mesh again, but now with Mesh compiler. Let me see if I can parse that. Let's see. So yes, I'm writing a compiler for Mesh in Chibi right now. Yeah, that could work. Basically, what it sounds like is I'll compile the code using Chibi at first, but I'll have all the underlying toolchain be written in Chibi. Then I'll convert the compiler to Mesh whenever it can finally do all the tasks for compilation, and then still use the underlying Chibi toolchain, the assembler and linker, and then gradually go down the stack and bootstrap those bits. It's possible that I could do that. I'm hoping to get to some point where I could do some bootstrapping, because it'll be pretty fun. But it's going to take some time, because the more I make progress in, the more I realize how much work I'm going to have to do to get even the bare minimum. Drishel says that was sarcasm. I figured that was the case. Let's see. Pavel says, then write a compiler for Chibi in Mesh to complete the circle. Yeah, for like a half second, I consider that just as a joke. Dinesh says, does anybody here know assembly? I'm really interested to learn it. Could get some suggestions on some source materials. There was a book that I started reading, but I don't remember the name of it off the top of my head. But yeah, like there's a lot of resources online to learn assembly. It's actually a lot of information is out there for that. So I also think it's worthwhile to try to mess with it a little bit, because you get to understand what's happening at a very low level. Like even with calling a function, whenever you call a function in a programming language, I mean, you sort of assume this is just the way things work. But in the end, what actually happens is the compiler turns that code into a series of instructions which conform to what they call a calling convention, where you have to put the parameters to the function in particular registers, and the register you choose for a particular parameter depends on the type of the parameter in a lot of cases. And then you have to use a specific instruction to invoke the function, and then it will look for all those parameters in the registers and also on the stack. So it's interesting to learn how all that works, because I mean, you don't necessarily need that information on a day-to-day basis, but if you do know it, then maybe you'll be able to think about how you might be able to optimize your programs in the way that you write them. So kind of interesting. Let's see what else we got in the chat here. John says, play alligator eggs game with your young children to teach them lambda calculus. I've never heard of that. That sounds pretty cool. Ashraz says, given that all of this is Lisp, David could probably add a mesh to Chibi compatibility layer for the bootstrapping, similar to the CL library in Lisp. That is true. Yeah, probably could have it be the sort of the syntax of mesh that is interpreted in Chibi. EC Gate says, I would start with NAND to Tetris or learn an assembly for simpler architecture like MIPS or something. Yeah, so x86 is pretty wild. Learning how to encode x86 instructions, I'll talk about that in a little bit. That's it's pretty interesting. Definitely a simpler architecture would be better to learn, because the register set will probably be more understandable and the instruction set will be more understandable. So I think, yeah, that's a very good suggestion. Smoke Inspector says, why do I keep getting no protocol specified when I log into EXWM? That's probably something that you need to run. Ask me that later in the stream and I'll see if I can help you with that. GK Suda says, what's your views on Elfer? Is it something you use in your setup? I do use it, but I've seen other people have trouble with it. I've actually never had problems, so definitely we could talk about that later. Okay, so the rest of the linker is just basically a bunch of sections or a bunch of functions for writing everything out. So the main function here is the link executable function. And what I'm doing is taking in the path to the executable to be written out and the list of object files to combine to put into the output. First of all, I will combine all those object files into one, which is a whole other process on its own. And then I start gathering information about the combined object files to start making the sections that we were talking about before, the headers for those sections, the text part of the program, which is the actual instructions, and the elf header, which is the thing that goes at the top of the file, which basically says where all the other sections in the file are. It also says that this is a 64-bit executable, all that kind of thing. So we put all these things together. If you haven't looked at Scheme before, this is similar to Emacs Lisp. So if you follow the Emacs Lisp series, this may look a little bit familiar. We have a let expression here, which basically creates bindings for all of these variable names to the values that are here in the second part of this list. And we're using let star so that we can refer to names that are bound earlier in the list in later expressions. So here I'm referring to combined, that's being defined here. And then if we didn't use a star on the let, that wouldn't be possible. It would basically say that combined is undefined. So just a little bit of a scheme detail there, or Lisp detail. And lastly, I'm calling write object file to take the appended parts of the file. So basically I'm taking all these lists of bytes that I've created from all these different sections of the file, and I'm appending them together into one big list of bytes. And then this write object file function will then convert that into what's called a byte vector, which is more of like an array of bytes, and they just write that straight out to the file. So F Society, I'll do that in another video. Probably I'll do a .file detective on myself at some point. So that's sort of the high level aspect of how the linker is working. I don't really want to go through all the code here because it's probably just make your mind numb. But yeah, if you want to take a look at the code, I have a link to it in the show notes. In fact, I can grab this link and just paste it into the chat really quickly. It's been a lot of fun, and I think that I've gained some productivity writing this in Scheme instead of C, because I can use some functional programming patterns here. I believe I'm using folds around in certain places, which is pretty useful for putting together blocks of things. Headers, did I do this the right way? Interesting. Anyway, I've been able to use some of the niceties of Scheme to speed up this process. I'm also using a lot of plain lists as data structures everywhere, which is great for moving quickly, but then it gets a little bit annoying when you start having nested lists and you have to start dealing with those. So I think that soon I'm going to start using more structured definitions for some of this code so that I don't have to drag too much on list handling, using car and cdr and all those nice functions. Hi, Jafer. So let's quickly look at the assembler so you can see what I was doing there. If there's any questions anybody has about anything that I'm doing here, please feel free to ask also. I'd be happy to go into more detail on some section of it. So the assembler, I think, is pretty simple at this moment. Yeah, it's only about 53 lines because it doesn't do a whole lot. So the top level function here is the assemble function, which takes in what I call the code spec, and let's see, interesting. And I'll call this process code function on the code section. So the code section is the list of instructions that we have in the main file here. So this basically this section of the list. So this is the thing we're looking at, is this list of symbols that have instructions behind them. So process code will then take the list of instructions and then call encode instructions on that, and then put everything together. So since we have these symbols that are mapped to sections of assembly instructions, we have to then take those symbols and then know the location of that function based on the symbol, because later, whenever some other code wants to call a function that's defined by a symbol, we have to know where those functions are defined. So we have to keep track of the location in memory where that symbol is defined, or where the function's instructions are defined, basically. And I'm basically putting all this information together based on these symbols that are placed in the file. I have to keep track of where I am in the list of instructions based on the size of each instruction. I have to calculate the memory locations and then keep track of the location of a particular symbol definition effectively. And then once I have that, then I can basically write out a list of symbols and the machine code as an array of bytes. And then that's what gets given over to the linker to then put together all the object files and then create a binary out of it. So let's see, encode instruction. So right now, encode instruction is stupidly simple because I just needed to make those two instructions work. So I'm only just looking for the move and the interrupt instructions, and I have specific functions for encoding these. The code that I'm working on now is different than this in that I need to be more flexible, because the move instruction could have many different formulations. It depends on which registers you're trying to use. It depends on whether you're trying to move something from a memory location into a register or vice versa. It depends on what type of value you're passing in. There's all kinds of different combinations of different ways to express a move instruction. So it is it's a process that I had to wrap my head around. That was a whole nother thing that I had to learn about, which is how to encode instructions in machine code. So if you have a higher level instruction like the one that you see here, this move EAX1, how do you turn that into the relevant machine code? First of all, you need to know the opcodes for your particular architecture. And I'm going to pull up a site that I've been using to learn this, and it's going to probably melt your brain because it definitely did that to mine, but you'll see in a second what I mean. So x86 assembly, or x86 itself, has quite a lot of operation codes. Man, this thing keeps happening. It's getting a little bit annoying. All right. So there's this huge list here of all the different, maybe zoom in a little bit here. All the different the different instructions you could pass to the processor. So you see there's a whole bunch of them for and, there's a whole bunch of them for add, and there's all these encodings for what the operands would be. So an instruction can take two, or it could take up to two operands, I guess. Maybe it could take more than that in some cases. I guess there's 3 and 4 here. But the operands are what are passed into that instruction to perform some task. Sometimes the operand comes from a register, which is a specific memory location for the CPU that's very fast to get access to. Some of them come from actual locations in the memory of the process, which takes more work to actually pull that information to be executed. And as you can see, there's kind of cryptic descriptions of what the operands are supposed to be. And some of these say they can be 16-bit, they can be 32-bit, they can be 64-bit operands. And to access those, you have to do special things like with bytes that come before the operation code for an instruction, or bytes that come after the operation code. It really just depends on the specific instruction that you're trying to execute. So learning this is at first very, very confusing, because at least with x86, there's like a bunch of different ways that you can customize a particular operation, and there's many different opcodes for the same type of thing. They just depend on what type of operands you're passing in. This table is pretty helpful, but only after you start to understand what all this stuff means. Before that, it just looks like gibberish. So I definitely don't recommend going and try to understand this as the first thing that you do. There's another resource that was a little bit more digestible. It's this page for x86 64 instruction encoding on the OS Dev Wiki. And if you look at that, it will, if it opens in the right place, there we go. It explains all the different parts of the instruction encoding for x86. And this also doesn't make a whole lot of sense because it's written sort of as a reference and not as a walkthrough. But it was helpful for me to see it written out in certain ways to understand what all the different parts do. I've written code that is able to handle a lot of this stuff now, but it took a while to digest all this information. One other thing that was really helpful was this article, Understanding Intel Instruction Sizes. It's a little bit out of date because it was actually written as many years back before the 64-bit Intel architecture showed up. But it does explain a lot of stuff that's really useful about the Intel instruction format. And I think this was the article that actually unlocked a lot of the knowledge for me, because before that, I was very confused about how the processor knew for each operand that you pass into an instruction, how big the operand is, whether it's 16-bit, 32-bit, 64-bit, etc., or which register that was supposed to be getting used by the operation. So this article was very helpful for that. I'll leave links to this in the show notes after we were done with this. But all these other prefix bytes that it talks about is very useful information. The mod rm byte, which is more customization for an operation, and is kind of, it encodes a lot of stuff into one byte. It's pretty interesting how much information they're able to put in there. And it also leads the way into there being yet another byte after that that has even more information about the operation. So it's quite complicated, and if you were trying to write code that either encodes or decodes x86 assembly, you have to know that there's any number of bytes that could show up in an operation. It could be from 1 byte up to, it could be 6, 8, really, it could be way more than that. This really depends on how many things are going on in that operation. So it's been an interesting experience overall, I would say, trying to digest this information. However, it's been very fun, I would say. Tedious at times, but fun. All right. So EC Gade says, I recommend checking out a couple of Pio Marta papers, specifically making colas with Pepsi and Coke. Interesting. I don't know anything about that, but I'll certainly take a look. PEG-based transformer provides front, middle, and back-end stages in a simple compiler. I'm certainly interested to hear about those. Marco says, could you elaborate a bit more on parsing in Lisp? So luckily, I've been able to avoid that for now because I can just make use of the read function in Chibi Scheme. Since I'm writing a Lisp based language, I'm able to use an existing Lisp reader to read in S expressions and then just handle them using the normal functions inside of Chibi Scheme. So the parser is something that I'll wait until later on because I really don't need it. The idea is that I'll use Chibi's reader to parse in Lisp data structures until probably at the point where I'm ready to bootstrap the language, because I don't need to, that's sort of like the most straightforward part of all this. So parsing Lisp, obviously it's easier because there's not as many variations in syntax. The structure of the language is all in nested lists. So if you can write a recursive descent parser that just looks for lists, then all you really have to know how to parse are lists and symbols, strings, numbers, and maybe any kind of customized reader expressions. And that's really it. I mean, for a basic Lisp parser, you don't need a whole lot. I've written one recently in C, and it wasn't that bad. So yeah, I'm just saving that for later because it really isn't needed until much later. Okay, so I think we talked about the areas well enough for now. Also, the challenges, yeah, basically was saying that understanding the ELF format and generating it correctly was definitely challenging. I had to do a lot of research on that, and also the x86 instruction encoding. I'm still learning a lot. What I decided to do while I was trying to figure out how to write out the machine code correctly for the instructions was maybe it would make sense to write a disassembler at the same time so that I have I can learn it from both sides. I can try to learn how to decode it so I know all the possible structures of an instruction, and then also be writing the assembler that converts to machine code at the same time. One thing that gave me some ideas about is how can I have an intermediate format for an instruction where when I want to change assembly language into bytecode or machine code, if I can turn it into this intermediate instruction and then from that turn that into machine code, then from the reverse, I could have machine code that I'm reading and then turn that into the intermediate instruction, then turn that back into the original assembly. So I'm thinking there's probably a way to do that, and there might also be a way to generalize how I handle instructions based on the expected operands and the expected prefixes and all that kind of thing. So there might be some interesting design in the assembler/disassembler combo at some point here soon. All right. So next steps for the language, or for the tool chain, I suppose I could say. I really need to write encoding and decoding for more instructions. So to actually have anything useful happening, I'm going to have to deal with things like mathematical expressions, jumping to different points in the memory, calling functions, which I'm not sure exactly how I'll deal with calling functions just yet because I want to use continuations as the core model for execution and not necessarily use typical stack-based function execution. I don't know enough about that yet to speak intelligently on it, but what I do know is that a lot of scheme implementations are developed with a continuation passing style as the intermediate representation, which basically means that you can do a lot of optimizations and interesting control flow structures with that whenever you have that kind of setup. So I need to figure out how I want to do that before I get too far into doing function calls and whatnot. I also need to figure out a way to detect instructions that use memory addresses and then update them. So one job of the linker is that whenever you're combining together all the object files, you have to, whenever you're writing them together in one file, you have to update all the memory addresses for things that are referenced in the memory of a particular object file. So say you have one standalone object file, you have a bunch of instructions that are doing things in that file, and then you have data defined in that file for variables, maybe global variables or anything like that. And whenever an instruction refers to a data address in the same object file, once you move that object file into a combined file that has a bunch of other object files, then those memory addresses that you use in your instructions inside that single file have to be updated to be in context with the larger file. So the linker has to go through and basically detect when memory addresses are being used, and then has to update those to be relevant to the new position in the output file, which sounds kind of crazy, but I think that if you have the necessary code for looking at instructions, then you should be able to see, oh, okay, this is an instruction that I recognize that takes a memory address as a parameter. So I'm going to assume that this operand here in this instruction is a memory parameter, or sorry, a memory address, and I'm going to update that based on the locations in the new file. So I think some of the work that I'm doing right now, writing the disassembler, will help with that because it gives me the code that can detect or basically read an instruction and then understand what type of operands that it's taking, and then know that one of them is a memory operand. So that's interesting. Might be kind of fun to write that. Writing functions in assembly and calling them. So I haven't gotten to the point yet where I'm calling functions yet. I need to do that at some point, and I'll try to get a basic stack-based function calling system set up as well. But yeah, that's another thing I haven't learned how to do yet. So another nice little learning opportunity. And then once I'm at that point, I can start making small sort of non-trivial programs, but only in assembly that works in my tool chain. At some point, I'm going to have to start, writing higher level code in my language that gets converted to that assembly. So I'm not going to deal with that just yet. I just want to make the tool chain a little bit more capable so that then I have all of the necessary infrastructure in place where I can start working on the higher level representations, and then start working on the compiler bits that turn everything into this assembly that then plugs into the rest of the existing tool chain. I'm very excited about it because it's a lot of fun working on this stuff. Like I said, it's tedious, and sometimes it makes you want to pull your hair out whenever you don't know how to do something, but I think that's it's been worthwhile so far. I've been really enjoying it. So I've got some instructions, some resources here that I've found helpful during this whole process. I've shown a few of them already. So if you're interested in learning more about some of the things I was talking about, you can check out these links in the show notes after this stream is done. But yeah, I think that it's cool to see for myself that this is not some sort of mystical art that nobody can do unless you're like a super geek or whatever. And if you have the patience and the time, you can definitely learn how to do this stuff and basically write your own compiler tool chain. Now, let's see what I say 6 months from now whenever I'm like deep in the weeds of trying to write a standard library and I'm not very happy anymore. We'll see if I keep going on it at that point. But at least until then, I'm having fun. All right, so the next part of the stream, I want to do some live hacking on something. But I'm going to let you choose this time. So I have 3 options for you today about what we could possibly work on. And I have this nice little link here for a website that will allow you to go and cast your vote for what you would like to see today. I'm going to go ahead and drop this in, and I'll explain what the options are. So the first option is working on a Gemini exporter for org mode. So a few episodes ago, I was showing you how I had started exporting the System Crafters website. Whoops. Go away. I started exporting the System Crafters website to, I clicked on that by accident, sorry about that, to a Gemini site. And it was nice to have a thing for that already, an existing package, but I didn't like the way that it output everything. I felt like it didn't write out clean enough output. So I thought it might be cool to try to write an exporter for Gemini that was more clean and it resulted in a better looking site in the end. So we could try to do that from scratch using the very basic APIs for org's export backend. Also, we could work a little bit on the Mesche Compiler. One thing that we could do there is that whole process of trying to update memory locations of things in the linked executable. I probably wouldn't be able to make a whole bunch of progress on that, but it is something that we could try today that might be pretty fun. And then the last one is continuing on that project that caused my computer to hang at the end of the last stream, which is writing a music player in Guile scheme. I still need to get back to that. Wow, why is this stuck? Go away, please. Anyway, yeah, so I would like to get back to that at some point, but we don't have to work on that today. And hopefully the next time that we work on it, I wouldn't actually lock up my machine. So I'll give a few more moments here for people to cast their votes. As you can see, this is updating live, so you can kind of see how people are voting at the moment. And you can only vote once, so choose wisely. Maybe you can change your vote, I don't know. So for some reason, I have an EXWM workspace change here that won't go away. Let me try to actually run that again. Control C, enter, no. Control C, enter. Please go away. I don't know what's happening here. All right, looks like Gemini exporter is winning at the moment. We'll see how that goes. Yeah, why is this just hanging? And I can't even click in there to get to it. Oh. Hey, I did it. I just had to move my cursor down into the mini buffer. All right. Cool. So it seems that the majority is in favor of the Gemini exporter at this point. So I think we'll just go ahead with that. And another time we can work on some of these other projects as well. So let's see. Org export. Let's see. I'll just look up org mode export. So Jiki Suda says, every Steam David never fails to break something. Yeah, whenever you play with sharp tools, sometimes you're gonna get cut, apparently. So let's see, is there anything about the back end here? I can try to look at the, I think it was OX Gemini that we looked at before. So the thing that I didn't like about the OX Gemini exporter is that they're using the OX ASCII backend by default. And I'm wondering if I could just avoid using that and just write my own backend straight out without having to use it as a default. I don't know if that's possible. We're gonna find out pretty quickly whether it's possible or not. This may be a total crash and burn situation, but we'll see how it goes. So I'm just going to ignore this for now. Yeah, so this is a very simple implementation because they are able to benefit from a lot of the ASCII export. Let's see. Manoj says, what is Mesche Compiler? I probably missed it. Yeah, we talked about it last week, and we also talked about it a little bit earlier in the stream. Ramsey says, sometimes a mini buffer stays open. Yeah, definitely. I had to move down to that window, basically, so I could cancel the operation. Topla says, yo, I've been watching you for a while. Hi, nice to see you here. So let me open up a new project for this. Projects, code. I don't know what I'm going to call this yet. So let's say OX Gemini clean. And I'll have OX, oops. Seriously? Okay. Okay. So we're starting from scratch here. And I'm going to cheat a little bit and look at the site generation code for the System Copter's website. And the reason why is because I need to grab a couple things here that I had started doing. Or at least, yeah, take some inspiration from it. Where was it? Okay, so org export define derived backend. So what I want to find is org export define. Okay, so there's a defined backend, and what does it take? So it takes a backend, and it takes transcoders, and then it takes a body. So we're going from scratch here. I literally have never written one of these before, so we're going to see if we can figure out how to do it in the remaining hour and 20 minutes we have left. So what we can see here is that we have a derived backend, which is deriving from site HTML, or sorry, deriving from Slim HTML, and it's something I call site HTML, and it has a series of keywords with sections. And if we look at the definition of the defined derived backend, what we'll see is it has only the body. It has child and parent, so it's different than the other one that we looked at, which has transcoders and then body. So transcoders is an A-list between object or element types and functions handling them. So what it sounds like is that this translate A-list is the same thing that we need to define in ours. So template, I think, is a top level one. In fact, let's look at the documentation. Does it actually tell us what they all are? In addition to element and object types, one function can be associated to the template or inner template symbol, and another one to the plain text symbol. That's interesting. I wonder if that's useful. So I'm trying to find if there's a list. Maybe it's in the manual. Org export options A list. Okay. That's part of the body. Good. So it would be good to know what the list of possible transcoders are, but we'll worry about that later. For now, what I would like to do is try to just define a backend. I'll go over to the Gemini clean file. Lispy is going to give me some trouble today, I can tell. So we'll call this OX Gemini clean. And I'll take this part out because we don't need that. And I think that should be enough as the basis for this. I'll leave these in for now. And I'll also define some functions for these. I'll need to know what the parameters are also, but I'll worry about that in a second. And let's see, OX Gemini clean. I really don't want to have to write this whole thing out every single time. So I'm just going to type OGC as the sort of prefix for these functions because I'm lazy at the moment. I don't feel like typing a whole lot. So headline, OGC headline. I wonder what functions that they want. I'm trying to think the best way to do that. Maybe it's in the manual. So export dispatcher, blah, 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 blah. I think we're too high up in the process. Let's look at the, oh, actually, let's look at index. Maybe if I try find the translator functions, what is it? They're called translate. So translate, nope. Translator functions. Let's try this. Doesn't like the right one. Also, let's look for backend, maybe. Nope. Back end. Nope. What else could we call that? Ashraz says, defining your own backend is in the appendix A. Thank you very much. Is it listed here in the index? Nope. I will go to the contents. Hacking. Okay, so thanks a lot, Ashraz. Export backends. Org export reference on warg. Defining a backend. Awesome. Okay, so I think we're getting there. Translate a list. Maybe. Eventually, you can create an anonymous backend with export create backend. Is that what I did? I did define backend. Okay. Appendix A4. Yeah, I think they link you to this part. Ah, okay. I think they tell you the parameters for these, don't they? Hash table, list of... Oh, no, that's all the properties, I think. Come on. Where's all the functions? So we had template, translate a list, backend specific filters. Refer to the filter system for more information. I don't think that's right. Obviously, this is a problem if the documentation does not tell me what I need to know for. So basically what I'm trying to find is that for each of these entries in this list, first of all, I need to know what are all the possible values that could be there. And also for each of these functions, what are the parameters that are expected to be defined in those functions so that I can define my functions correctly and have them called correctly. So yeah, it seems that that they don't give you a good listing of that. To grok these functions, see OX latex for an example of defining a new backend from scratch, and OX beamer for doing a derived backend. Okay, so here's what we're going to do. I'll look up org export define backend, and I'm going to go to the definition of this in ox.el, and I'm cheating here because what I really want to do is go to OX latex, or LaTeX, however you want to pronounce that. And here I should be able to look at these functions and basically copy what they're doing. So I'm going to look at the org latex or LaTeX template function. Okay, so it expects contents and info. And it seems they have a naming convention here, org LaTeX template. So maybe I could do a similar thing with mine and say org Gemini headline, org Gemini whatever, org Gemini headline. I wonder if that other library that I was looking at has that. Okay, apparently I've already closed that window. Control G has stopped working on buffer switching. Okay, so for headline, let's split this window so I can see both at the same time. Whoops, wrong way. Now I have to do this, which is wonderful. Okay. Jesus Christ, man. I forget which buttons I'm using for vertical versus horizontal splitting sometimes. I need to have bigger steps on these movement keys as well. All right, enough. Okay, so what we're going to do is go back to that org LaTeX file, and I'm going to look at org LaTeX headline. So it's like headline contents info. If I paste this in here, I should be able to just change this word to Gemini. And then for the LaTeX template function, is contents and info. All right, so the output of this should just be text, I would think. Looks like it. So I'm going to try something really, really cheesy and just put some arbitrary output. Yeah, Lispy is giving me real trouble here. Template. Just nothing useful at all. And for headline, let's say, was it string append? Or is that scheme? Concat, I think it's concat is a function name. Yep, concat. Concat. We'll just do a headline and then, is it contents? What's it called? Headline, contents. Let's see, LaTeX headline. Level. So there's all these functions you have to call to get like the relative level of things, etc. Whether it's a numbered headline, which I don't care too much about. Section format. One for the title and other for the context. Is this something defined in this file? Oh, no, it's not part of the let. Or is it? Yeah, it's part of the let. This is a very strangely formatted let block. Because usually you would have it indented. All of the bindings would be indented at the same column. But here they're not. They're indented like it's a different type of block. So that's very weird. And confusing. So section format. Where is content getting used here? So contents. Placeholder for the contents. Okay, they're just putting together a big format string, it seems. Fine. So I'm going to concat headline, that and contents. Headline's content is an org mode element. You probably want, org element contents headline. Thank you. So what's the difference between headline and contents in that case? All right, so org element contents headline. So I'm curious about contents itself. So I'm gonna throw that in there also just to see what comes out. And then we'll take these two out for now and only go with the ones that we know we can define. And let me see. I need a way to test this quickly. I'm trying to decide whether I want to run this as part of a script or if I want to run it in my current Emacs session. Let's just go with this here for now. Let's run it here. I'll eval the buffer. And cannot use unknown backend as a parent. What do you mean unknown? Oh, I have derived. My mistake. Okay, so that did seem to execute it. Also, I want to define a project. So if I go to publish.el here and take my project A list, I'll just take out some of this stuff when I paste it back in. And I'll delete that. So base directory, I wonder if I can put a whole path here. So probably I can. Projects, sites. What is the path there? Site. Okay, that's fine. And content, I think, is what I want to do. Publishing function, publishing directory. Yeah, I'll go with that for now. That's fine. And base extension org, recursive T. Yeah, let's see what that does. And I think I can just run org publish. Symbols function is void or, oh, yeah, okay. I shouldn't have done that. So publishing function, do I even need to set that? I need to set the right backend. What was I doing here? and the publish.el. So I have my site HTML backend that I defined. Okay, so then I was using org publish org 2. So maybe I can just run that instead. Org HTML publish to HTML. Org Gemini publish to Gemini. So yeah, I wonder if I need to define this function as part of this package. So let's just try that first. I'm gonna delete that. Org Gemini publish to Gemini. I'll leave that for now, even though it's probably not correct to leave it there. And then I'll use this here. Org Gemini publish to Gemini. I'll evaluate this function, and then I'll reevaluate this part here as well. And then, let's see, can I also just invoke one specifically? Org publish all t. Okay, that works. So I'll just say org publish all t. And then, oh, whoops. Let's run that. Okay, get article output path is a function that I've defined in the other file, so I shouldn't be using that now. Let me see if I can just get rid of that for now. Hey, Vibov. Maybe I can just delete that entirely. And let's see. Ashraz says that since headline is not a recursive element, the actual content is in contents. The export documentation is slightly lacking. Yeah, definitely seems to be the case that it's lacking. So we'll take that out and we'll just use contents for now. And I think article path, lambda extension, symbol function. Do I even need that? Maybe I should just take this whole thing out. Just to get a raw publish for now. Or publish to Gemini. Whoops. Okay, that should be good enough. Maybe I'll just eval the buffer to make it faster. Okay, so did it actually run or did I throw an error? Okay. So unknown nil backend. Okay, I think I need to fix that. So I called the backend ox Gemini clean. Maybe I'll just call it Gemini clean. Reeval this to re-register it. And then I'll put Gemini clean here. Evaluate that. And then go reevaluate org publish all. All right, so it seems to be doing something. Maybe I should have a smaller folder of files so I don't have to wait for that whole thing to go through the whole time. So now we have a folder called Gemini, and we have some output files, and they seem to be empty. So there must be a top-level function that's needed for writing out the actual contents whenever these things get written out. I mean, we can see that it's working to some degree, but not working so well at the moment. What I want to do is go copy one of the site content files. Maybe we'll copy the show notes from the previous stream. Oh, I haven't synced that yet. So we'll copy the latest. We'll copy the introduction to Guix here. I'll go back to the code / what was it? Gemini clean. I'm going to create a new directory, content, just for test purposes, and I'll paste it in here. All right, cool. So now let's kill this buffer. Why did it go to an edit macro? Control X, K, return to cancel. Okay. So I'm going to go back into this file. I'm going to change this project. Things are running really slowly all of a sudden. I'll change this folder to ./content so that we're going to use just that one content file. I'll go ahead and delete this Gemini output folder since I don't want that to be there. And then reevaluate this to reset the project and then run this one more time. Okay, that was only one file being exported, which is great because now we don't have to wait. Okay, so what we'll do is open up the output content file here and clean the Gemini file for introduction. And then whenever we make changes, we should be able to see this in the output. Ashra says, instead of org publish, you can probably use org export to buffer on an org buffer just as a single file to a buffer. Yeah, I might try that in a bit, actually, if it turns out to be too slow or problematic to do it this way. I think for now, though, we're in a good place to continue. So we need to find out why nothing's being written to the file to start with. We must be missing something fundamental. So I'm going to go back to the OX LaTeX file. I'll go look at their backend definition and see if there's anything obvious here that we're missing. Paragraph, section, maybe section. I don't know what that is. Target, template. Okay, so let's search for template in the file. Let's see if we're missing anything template related, because I think template must be the top level. Okay, what's this make preamble? Come on, can't type. All right, so this is in which function? This is in the template function. So in theory, this should be the one that is going to write out the basic body of everything for us. So I must be missing something. Org export data plist get info title. So it's grabbing the info of the document. Org export data. Org export data. So I see a lot of org export data calls. What is this function? Convert data into the current backend format. Okay, so that might be one thing, because it seems that this could be what invokes the other template functions, I think. So yeah, export data date. And info in this case is, okay, the current info and then the date. And where does info come from? Info is at the very top level. It's probably just one state object that's being passed through all the functions. That makes sense. So let's see. There's a cond here at the end. And there's a concat. Get latex command. Documents body contents. Where's that coming from? Okay. Oh, the document body. Okay. Huh. So is it possible that it's not creating some of the lower level stuff in the file? Because content seems to be a string that exists already. I wonder if maybe we should write out what we're getting as parameters here. So if I were to say message contents, we'll find out. Oh, yeah, let's do that here actually. Contents, and with a %s, contents. I'll reeval this function, and then let's try running this one more time. Can I just run org publish all? Cool. All right, that should work. So I didn't see anything come out in the message buffer. So it makes me think that that's never being called, which is very weird if that's the case. Oh, that's because I'm not putting the right functions in. That makes sense. Weird that it didn't actually throw an error saying that it can't find them. So org Gemini template, org Gemini headline. I have bash script. Okay, so we'll reevaluate this, and then I'll run one more time, and then, well, let's just leave the message buffer here. So org publish all. This might have been written out from that. Let's see what it says. That didn't work. Okay. Org Gemini template. We'll just do some print line debugging here. And then reeval this function. Actually, let's reeval the whole buffer just to make sure. Because who knows. All right, now I'll go look at the messages one more time. Cool. I think that's doing something now finally. And this says here's a file. Cool. So that now we have the basic stuff working. At least we can see that the contents are being written out correctly. So what I'll do in that case is change the main function here to not say that anymore. I'm just going to say contents in this case. So contents, don't need these anymore. If I re-eval the buffer, then I should see now that the contents are here, which is great. And for the headline, interestingly, the headline does not write out what the headline text is. I know there's text on this headline, so I don't know why all of a sudden it doesn't work. So let's write headline. It's probably going to have a plist, but we'll see what it does. Wrong type argument character p headline. Okay. So maybe if I message that one, yeah, it's not a string. Obviously, it must be an object of some sort. So headline, and then headline. This is where a debugger would come in handy. And then if I look at this, then there's a bunch of junk in there. Is that all the contents of headline? Because that would be insane. Am I in the right place? Headline, raw value. Okay, so where does this end? At the end? Why is all this other stuff in here? Section. Okay, so it seems like there's a section after, and probably what it's doing is it's got a hierarchical design where a headline can have sections under it that have paragraphs inside. Okay, so we see that. And then we see there's a paragraph here. There's also a paragraph before, another paragraph before, another paragraph before. And then this is raw value. Okay. Interesting. So let's go look at the headline function of org LaTeX and see. He's put me in the wrong place. So LaTeX headline. Org element property, footnotes section, don't care about that yet. LaTeX class, so there's some extra metadata that's baked in, it seems. So we can definitely get the level. That would be useful to have so we can write out the number of stars, or no, the number of hashes for the heading. Yeah, headline is a recursive element. You need org element contents after all. Okay, so that makes sense. It does definitely make sense. Let me go back to the file. It's unbelievable how long it's actually taking me to switch buffers right now. So let's do that. Org element contents. Thanks a lot, Ashraz, for the help. Element contents. So that should solve that problem. We'll eval the buffer one more time. And I think that because I did... Oh. What didn't you like? Wrong type argument? Or is that on contents? Let's try that. Saw a lot of angry messages. Oh no, I printed things out, it seems. All right, so let's take that message out because it's just causing way too much chaos here. Run it one more time. Okay, so I don't see it actually writing any content out here. Maybe if I change this back to headline, will it work? No. Wrong argument type, character P. Org element contents. Let's look at that function really quickly. Org element contents. Extract contents from an element. That should be the headline, I would think. And if we look at the content... Contents end, contents begin. We want the contents of the headline itself. Oh, it's pulling the section out. That's a different thing, I think. That's going to be the body of the headline, I think. So what about the actual headline text itself? Maybe I'll have to just grab it from the plist. It's a lot of garbage to look at. I apologize for that. Headline, raw value. Yeah, that's weird. I feel like I should be able to get that more easily. I don't trust raw value here. What is GNU Guix? It's title. Headline, title. Is that what it is? Title. Title. That's a weird list here. I think it's better to just pull the raw value. Let's see what OX LaTeX does. Org export numbered headline P. No, that's a predicate. We'll just skip on down a little bit. Headline label. Where does that come from? Headline label, org LaTeX label. Okay, that's a different thing. That's for their output. Is there a title? Org element property title headline. Org export data with backend. Yeah, I think that's it. Title headline, org element property. So that looked like the list before, but we'll see what it looks like whenever I use it. So let's say, try that. Eval buffer. Gee. Let's do this one more time. And what was the error this time that it didn't like? Wrong type argument, character P. It's propertized, it seems. Why don't you like that? Org element property. Title headline. Export data with backend. So maybe I need to do that. Export data with backend. Convert data into backend format. Section backend. What is that? Section backend. Org create, export create backend. Wow. Thanks, Hackintosh. So it looks like you can create derived backends in line that override certain parts of this. That doesn't seem like the right way to do it. That seems kind of strange. Unless you really need to customize the behavior in a very scoped section. So it seems like you wouldn't need that. Org export get alt title. What does that mean? Return alternative title for headline. So org export get title or get headline number. Content. This is going really well, I gotta say. The lack of documentation is helping out a lot. So if I go back to this page, is there any like tips I can get? Let's search for content. Contents. Okay, I'm not really getting any info here. Export data. Transcode a given element, object, secondary string, or string using the current backend. Transcode secondary strings like title. So let's see. For the template, contents, if we want to get the title of the document, let's just try that really quickly and see whether this looks right. So for the template, I'm going to try to export the title. Maybe I didn't pass info like I was supposed to org export data before. So I will go back into this file. And then for the template section of this, I'll say concat. I'll have contents there, but I'll also put the title in first. Oops, let's just go with this part. Org export data. plist get info title. Let's see what that does. And oh boy. Let's see if the parentheses in my file are totally screwed up now. All right. And I need to change this part. I'll just do that for now to save us some time and headache. All right, so an introduction to GNU Guix, great. At least that seems to have worked correctly. I can put a... How are headlines supposed to look, or document titles supposed to look in Gemini? Gemini gem text format. quick introduction to Gemtext markup. Wow, that looks terrible in this browser. Heading, subheading. Probably the top level heading would be the title of the document, technically speaking, if you want it to be that way. So we'll go with that. We will say that the title of the document is going to be at a level 1 heading. And then after this, I will put a new line. Wow. All right, let's put 2 new lines just for the sake of aesthetics. Okay, so now eval buffer again. Okay, so we have an introduction to GNU Geeks. Great. Let's see. Now we're still not getting the headline information. I think once we figure out how to do this correctly, then the rest of it will come a lot more easily. So now if I were to jump back in with this headline, I need to look at what the headline text contains one more time. Or the headline object. There's also contents, which is kind of confusing to me at the moment. Yeah, I'm a little bit worried, Ashraz, about wrapping it with org export data, because I don't know if it's going to try to do some kind of recursive call that's going to lock everything up one more time. Let's try contents. I just want to see the body of contents. If this works. I probably did this already and had trouble with it. What the hell was that? All variables and subroutines might as well have a documentation string. Okay, that must have been from fly check. All right, so this is... Huh. I think... Why talk about GNU Geeks? It feels like that's the actual content of the headline. So, org element content. Org element contents. Extract contents from an element. What about org element contents contents? Might not work. Is it the same thing again? Yeah, it looks the same. So it is a vector. I mean, obviously I could just grab the first thing out of the vector, but that seems to be the wrong way to do it. We're going to go back to OX LaTeX again. All right, so now LaTeX headline. So org element property. Yeah, maybe what you said is true. Wrap it with org export data. So let's try that. Let's just see what happens. I'm going to try using org element property. Context variable is nil according to the log if I got it right. Other line is character P error message. Oh, is that right? Oh, no, you're right. You're right. You're right. That's absolutely right. Org element property title headline, and we're going to call org export data on that with info. So now let's just give that a shot after I get rid of this message here. I'm going to run this now. Hey, there it is. Good call, Ashraz. That worked. Okay, so now I kind of want to make this relative, the number of heading characters relative to the depth of the headline. And Gemini Gemtext only supports 3 levels of heading, so we're going to have to clip that off basically at 3, I think, which is a little bit unfortunate, but that's fine. I tend to like to have a little bit more nesting in my documents, but that's not a really big deal. Level, if we go back to this file, I think that we did see a way to grab that. So get relative level, I'll pull this in. And I don't know if there is a function that exists already for generating a string. I think I covered that actually in one of the videos, and I can't remember now. Make string? There's no make string. Oh, there's make string. How about that? Length init multibyte. So return a newly created string of linked lit with init in each element. Let's try that. So make string length 2, and then hash characters. Wrong. Oh, I need to give it a literal format for that. So if I do slash hash, what is the right thing for that? If I eval a hash character, no. Is that gonna work? Garbage following expression, of course. So Emacs character literal. Basic char syntax. Oh, it's question mark. Okay, so question mark hash. Boom, that's it. All right, so let's go back to this file then. Oh, and then I want to do it here. So I'll do question mark hash. I think this should give us what we want. Cool, so that's 2 hashes. So now I can say, well, I don't even need that. Let's do it nested. So in this case, I'm going to do a concat, and I'll call make string. Let's just say level for now. We need to fix that later, but we'll just say level, and we'll say question mark hash, and then we'll put a space character in between, and that should be enough. Let me eval buffer, and it didn't seem to do anything, which is interesting. Maybe if I write out the level that it's given me. All right, so for the message output, level 1, level 2, so that should be working. I wonder why that didn't actually do anything. Unless I am missing. Oh, you know what? I bet that I'm not getting nested headlines. And in fact, I need to add 1 to this value so that I leave enough for a header. I think that function works for the title of the document. So let's do this really quick. Eval buffer. I'm not, oh, okay, so let me just do this then. Okay, so now we have 2 things for that. And there is a max function. Is there not a max function? Let's see, max, okay, so there's max, number or marker, and I think if I say max 4, 3, oh no, min 4, 3, that's what I want, min, level, and 3, I believe is what I want, so that I make sure that I don't go past 3 hash characters at the beginning. Okay, so now I need to write out the content under this headline. I believe that's what is going on here, is that I don't see anything below. I don't see any headlines below because the content needs to be written out. So I can also concatenate a new line here, or let's say 2 new lines. And maybe we can do org export data contents info and see what happens here. Eval buffer. Okay, I'm seeing subheadlines at least. That's great. Good sign. So probably what I need now is a way to export paragraphs. So if I write out defun org Gemini paragraph, contents info. We'll have to double check that this is the right function for that. Latex paragraph. Paragraph contents info. Apparently is just pass the contents back. That's cool. Paragraph contents info. We'll do the same thing because these are unused. Paragraph. And then we'll run it again. Okay, so we don't have any output yet. And I think it's because we haven't written out sections yet. So LaTeX section, same thing for that. It's the contents. We'll just clone this. And, oh, no, you know what? I didn't add it to the list of transforms yet. So section, whoa, thanks Lispy. Section. All right, so that's good for that. Let's go down here and add them to these. So section.org Gemini section, and then we'll clone that, and then we'll say paragraph. Okay, so now if I run this again, we get a lot more text output. And we have some extra spacing in here. I'm not sure exactly which elements are accounting for that, but we do have a document that's being written out for the most part, which is good. I think it's good process, or good progress. No more hand editing of files in something. So apparently we're missing code expressions, it seems. If I were to write out an exporter for code, org Gemini code, I think that that would solve that problem. Let's see if the output Gemini from the site has that. So site, Gemini, Geeks, introduction. So what was it that I was looking for? It is right. Okay, yeah, so it has the backtick syntax. Oh, is that backtick with a closing quote? Okay, if that's the case, that's pretty weird, but let's see. Maybe that's the case. Let's see, gem text backtick. Oh, come on. Now we're going to look at this page again that doesn't render correctly in my browser. So backtick, literal code. Okay, so maybe this is sort of a conventional syntax. Yeah, that makes sense because Gemini is a line-based syntax. So whatever you put in the text is just literal, whatever it is. So in the case of code, that should be pretty simple. I wonder what the other one is. There's another one like code. I think it's verbatim. Yeah, verbatim. Let's check that one out. Yeah, whatever. I think that we'll just make these be exactly the same. So for code and for verbatim, they'll be the same. For verbatim, org Gemini verbatim. And for these functions, I'm going to guess that they, let's see, verbatim, clone that, and then I'll put code here. Oh, come on. Okay, we have those functions now. They are registered, and if, oh, let's get rid of that. And I should be able to just eval the buffer, and now, yeah, okay, so now oh, this is the wrong document. Let's go back to this one. So it didn't seem to actually print that out yet. I wonder why. There's probably something wrapping it that isn't causing it to be written out yet. Unless I'm mistaken about that. Let's try to revert the buffer just in case. All right. So now let's see. We have code, we have verbatim, they both have functions. The contents don't seem to be written out. I'll try running this one more time, just see, oh, you know, yeah, I think I did that right. And right. I'm trying to figure out where I had written something out that was a verbatim text. I guess I could just look for backtick. Yeah, there's no backtick in here. All right, let's see what else we can find. So if I were to write out the contents, well, let's just go back to the maybe if I check here, I can find something. Some of the output we had before. If I look for verbatim, okay, there's a verbatim, and the verbatim is directly in line inside of the content. That's weird. So there's a value of straight.el. It's in the middle of the paragraph. Backticks with closing quote is GNU style, which are also used by org ASCII export. Ah, that explains why the other one is using that. So probably I wouldn't do it that way. And I forgot actually to, you know, maybe they are being written out. I just can't tell because I didn't write out the ticks around them. So let's try that really quickly. That's probably what's happening. So format, 2 ticks around a string. You know, I can just use the same function for both of those. I don't have to have a separate function for that. And then I'll say contents here. I'll delete that line. I'll go down here. I'll delete, well, let's just change this to code. That was the one I kept, right? Yeah, code. All right. Let's rerun this. Eval buffer. Ah, okay. So it is being written out correctly. Great. So we can see here it says think nil, but for programs. I would imagine that many Gemini renderers would actually render that correctly or highlight it somehow. So that's a good thing to have in the buffer. Yeah, there's a few instances. Oh, nil. Okay, that's wrong. So maybe I need to do something with the contents after all. Wonder why. So org export data contents info. Is that right? Can't be right. Definitely not right. So value as variable. Oh, okay. Yeah, that's my mistake. I'll change this if I have to. Empty. But contents actually has something in it, right? So message, contents, contents. Run it one more time. Check the messages. Contents nil. So why would contents be nil in this case? Unless I'm looking at the wrong thing and it should be code. Let's grab code here instead. Variable binding depth exceeds max spec PDL size. That doesn't sound good. Oh, do I need to grab an element property out of that somehow? I wouldn't think so. Must be doing something wrong here. So let's see, what else can we do for now, since that's not working perfectly at the moment. So I had contents before and it wasn't writing anything out, I think. Let me just try that one more time. Yeah, I think that, so install those using something there. So if I were to just pass through contents instead, I think it doesn't write anything. Hi, Cherry. We were writing an export backend for Gemini in org mode, for org mode. And it's not working so well. So let's see. It's interesting that the LaTeX backend has these functions defined very simply. LaTeX code. Oh, LaTeX text markup is doing something there. Org element property value code. But for verbatim, it didn't do that. What did I look at before? Obviously, I looked at the wrong thing, because I swear that it actually said, it wrote out contents directly there. So apparently it's not right. Org LaTeX text markup. Okay, so what I'll just do then is do the same thing here. I'll just grab the element property, the value, okay. So we will need separate functions after all, it seems. And in this case, I will grab the verbatim value. That just gives me the property. I don't know if it's going to write it out correctly. I also don't know if that's going to work. Okay. So I will pull, I think, LaTeX code as code out of there. But I have to pass in the info, right? How does that even work? Text markup. Where's that function defined? Defun org LaTeX text markup. plist get info. Okay, there's a lot of extra stuff there that probably isn't needed for us. So maybe if I just pull out this property, it should be enough. We'll see in a second. So we'll put this back as code, and we will put this back as Wow. Lispy likes to bite me sometimes. Verbatim. And this needs to be changed. Verbatim. This needs to be changed to code. That should be enough for now. Let me go down here and change this back to verbatim. And then eval the buffer. Okay, this time it's working. So it pulls straight.el there. What else do I have in backticks? Okay, virtual env, slash etc. Great. So this seems to be working correctly now. I just had to pull it the right way. So the one thing that is a little bit more complicated to do in this backend is how links are meant to be represented in gem text. So if you remember back when we talked about Gemini, the document has to have links on a separate line because it's a line-oriented syntax. And if you want to have a link, you need to place the link text after the section of the paragraph that the link is referred to be in. I think there's a convention for doing that where you have like a numbered link text basically, and then in the list of links below, maybe it refers to that number. So we have to find a way to generate that information for a particular section of text, like a particular paragraph. Whenever there's links inside of it, we need to immediately put a link section after. So we would need to find all links in the paragraph and then generate the text for that in the paragraph function. So I think here in Gemini paragraph is where we would have to do the work. So to do find all links and write out link list afterward. And that requires us to write a function that can find all the links so that we know what we need to put after the paragraph. And then in the context of the paragraph, we probably have to number them. And we may need to have a lexically scoped variable that can hold that count, which would be interesting if that works correctly. So one thing we can do here, can I like put that? Let's see, so Emacs make file lexically scoped. So we didn't get to talk about lexical scope just yet in the Emacs Lisp series, or at least not in any detail. What I want to do is make this file lexically scoped so I can make use of that in some parts of this. Where is the header? Emacs lexical binding header. Maybe it's here. Set the buffer local variable. Okay, so how about I do that? Buffer local add local variable, file local variable, lexical binding. Yeah, that's what I want to do. Add file file variable, prop line. There we go. Lexical binding T. There it is. That's how we do it. Okay. So now, whenever this file gets evaluated, it should use lexical binding instead, which should be helpful for us. And it didn't seem to break our current export, which is good. All right. So now let's write out the contents of a paragraph here. So $% we'll say paragraph. I'm just trying to get some insight into what's in this object. And then contents, if that works. And we'll run it one more time, eval buffer. And I'll go back to messages, jump down here. And it seems to just be plain text for contents, so we're gonna have to look at the paragraph object instead. I'll pull a paragraph here. And eval buffer. Yowza. Okay, so that was a lot of output. All right, so maybe I'll search for link. Okay, so there's a link here inside. So it seems that inside the paragraph S expression, plist, I suppose you could say, or the plist of that. No, it has a plist at the beginning, and then it has continued contents after, and then it will have a link somewhere. So what we need to do is walk through that list of things and find any list that starts with the symbol link. And then we can extract the information from it. So what I can do, let's see. If I were to use a fold, nah. Let's do this in a very naive way first so that we can kind of see what we're doing. So we'll do a do list, and paragraph itself, let's see, paragraph colon. So there's a paragraph. There's like sub-paragraphs. How does this work? Yeah, it seems like there's sub-paragraphs, which is very strange if you ask me. But since we know the structure, we could potentially write out the list of links either at each sub-paragraph, or we could write them out at the end of a longer section of text to make things less annoying. So we have some choices here, I think. Hackintosh says, have you ever used Vim? Yes, I've used Vim. I used Vim for quite a while before switching to Emacs. So we've got about 10 minutes left. So I'm going to see if I can get this working, at least at a very basic level, and then maybe we can come back to it again another time in the stream. All right, so... Hi, Pedro. So what I want to do is loop over paragraph. I'll just do this only at the top level paragraph. I'm not going to worry about anything below that. So let's see, items. Thanks, Pedro. Item out of items. Not a good name yet. We'll figure that out later. And then for each item, we'll see if it's a list. So is there like a... Come on. Help. List P. Yeah, there's list P. That is not what I look for. Okay, so if, or let's say when. When list P item. And we can also say and. When it's a list and the car of the list is equal. Oh, I'm thinking in scheme right now, apparently. Equal car of item is link. So let's take that out really quickly. And then we can just basically print that out. So I'm going to print out that link whenever it comes by, and we'll just see if we get anything useful there. So link, and then we'll put the cooter of the item here, and maybe that's enough. Then we'll still pass contents through. So let's run this one more time. Eval buffer, values void. Oh yeah, of course. I should have put paragraph. Okay, so let's see what's in the output in messages. Did I get a link? I think I may have gotten an error somewhere. Am I still writing stuff out? Let's see, message. Trying to make sure I'm not writing anything else out that's going to get in the way. So I have message there for link. Paragraph. Okay, that's only one. Maybe that is a link. Type. Wow. How much information is encoded into a link? Is that nested somehow? That seems wrong. There's a paragraph in here? What am I looking at? Maybe I printed the wrong thing out, actually. So do list is potentially walking through. Oh. So maybe I need the catter of the item. Okay, so that's the link. Nope. Yeah. Okay, let's go with that. I need the catter of the item because I think that it's returning the entire remaining section of that paragraph. So we'll run this now. and see what's in the message output. I think that's better. Yep. So we're getting all the stuff all the way to the link text. So now what I can do is try to run the org export data on the item itself and pass info. But I think what I need to do is I need to put that link back on the front. So I'll cons that with a link. Let's go over here. I'm lazy. So cons link, just to make sure that it has data in the right form, and then eval the buffer again. Uh-oh. Value is void. Okay, so that's because I did that. Run it one more time. Let's check out the messages output. And that's giving us no info. So I wonder if I need to take this off then. I love how that happens. Okay, let's run it one more time. Check our messages. Still empty links. So org export data. Oh, you know what? That's why. It's because I'm not actually writing a link transformer yet. And probably I'll have to, hi Osloy, probably have to just pull the info out myself. So let me just take a look really quickly at the, I think I understand how this stuff is working. Yeah, Osloy, we're probably ending the stream in like 5-10 minutes. So you caught the very end at least. All right, so sort element property. What was the contents thing we were doing before? Org element property, org element contents. Yeah, let's try that. I'll just grab org element contents out of this item. And I think that this function doesn't take anything other than just the element itself. I'll drop this info. Run it one more time. Look at the output. That's not what I expected. Link colon. Let's go to the end. Link colon. Path. That's not the content of this thing. But I wonder if I need to add that back now. Cons link. Nope. That's really strange. Let's pull this very last part. HTTPS path. Yeah, this is not giving what I expected it to. If I were to go back and write this out one more time, I would see that okay, link type. Oh, you know what? I might need to append. Let's try that. This is getting into really hacky territory, but I'm just trying to make it work for the end. All right. No. That's not what I expected. So I'll do this one more time, just for the sake of figuring out what's going on. And for this, it just needs to be like a little no-op, so 1, 2, I don't really care for right now. We'll look at the output. Go back up to this entry. Contents part in the transcoder's export functions is the already exported string of all sub-elements. You probably don't need to loop the paragraph. Well, I need to find the list of links under the paragraph, though, and I need to not write out the links that are inside of the body. So not having a link... Yeah. Paragraph, begin, and I want to see where a link shows up in here. So link So yeah, so link is, it has a symbol that shows up as the first element of the list, and then there is a list in the const that has the properties and then the text. So I need to make sure that the link that I'm getting is properly represented there. So I just needed to tweak this a little bit more. So if I, let's see, if the item is a list and the car is, so maybe I just need the item itself. I'm just doing stupid stuff right now. So let's go item. I think I tried this before and it didn't work though. Let's see. Yeah, because something weird is going on with the way this list is structured, I think. Paragraph, paragraph. I'm writing that out, aren't I? Oh, I've got that crap in here too, so it's going to be really confusing. Okay, so now let's go back to messages. And this is the whole link, I think. Link. But it's got a paragraph inside of it, which is just nutty, in my opinion. Why does the link have a paragraph inside? Because this is the properties. That's the whole property list, and there's a paragraph inside of the property list. Type HTTPS. Format bracket. Application search option. Contents begin, contents end, parent. Oh, it has parent information encoded inside. That is insane. I guess maybe that's necessary if you want to do backlinks somehow, or maybe include context in the link itself. But yeah, I wasn't expecting to see all of that there. But that explains some things. So maybe now if I were to ask for the content of the item, it will give me the right content. Org item, oh sorry, org element contents. Is that the right function? Yeah. Let's see what this does now. Now that I'm not causing it trouble. Let's go back to the messages buffer. Hey, all right, so now we at least have that, but that seems to be a list of symbols and not a string itself. So what if I were to say, I don't think this is gonna work, but we'll see. Org export data. And we'll do this and then say info, and then run it one more time. And go check out the list. Okay, so it did turn it into strings. That's good. Maybe it just treats a list of symbols as just a normal string in the end. So now we have the list of links. Maybe we can finish this really quickly and see it work. So for each one of these that we have, we now need to build a string, and this is where fold could actually be used. Is there a fold, right? Or a fold of any sort here? Maybe it's in a library. Emacs fold function. Maybe it's called reduce. No, wrong kind of folding. Jeez. Reduce. Come on, man. That's the problem with searching anything programming related with Emacs, is sometimes it's going to come up with like IDE or editor functionality instead. Reduce? Nope. There's definitely a map function, I think. Map. Oops. Oh, interesting. Map car. Make a list of the results. Alright, you know what? This is what I'll do. I'll map it and then I'll just apply it into a concat. So in this case, we're going to switch from using a list, and instead we're going to, so is that going to find it right? Yeah. And map is probably not the kind of map I'm thinking of. So let's go with map car. I think is what I want. So map car, apply a function to each element of sequence and make a list of the results. So map car, and I wonder if I can pass in a lambda directly. We'll find out soon. So lambda item, and then in the body of the function, I want it. Oof. Map can. Oh, there's map concat. Map concat. If there is that, Thanks, Ashraz. Ashraz is a fountain of Emacs knowledge. I think he's also looking things up too, but he's also very fast at it. Excuse me for using he. I shouldn't be picking pronouns for people. Let's see, map concat. So function sequence separator. Now the problem here is I want to filter out the ones that are not fitting in with this. So actually what I might be able to do in this case is just having an empty string. So here's what we're going to do. I'll drop this part in, make this an if I don't delete all my code first. So if, and let's just format that up a little bit. So if it is, then we will say format. I'll use the arrow syntax that is used for links. And this is not going to work perfectly yet, but we'll get it fixed up in a second. So the paragraph is the list paragraph. And then we also want to pass in the delimiter, which we're going to use as an empty string for now. And then we'll take out, oh no, we want that. And what we'll do here is concat. We'll have the contents, we'll have a new line, and then we can move this down and put it inside of the concat. And let's see. So we need the else case here, which is going to be an empty string. We basically want to ignore it. So now let's see if we can get that writing out correctly. I didn't see any errors. Oh, okay, so that worked. So watch the video, there's a link, and then we have a link there. We need to put some line breaks though, so I'll put a line break here. Eval buffer. Okay, so now we have two links here. We have a link there. All right, so the last thing I want to do is write out the actual link beforehand, because I think that the syntax is that you're supposed to write out an array, sorry, a link as a, come on, man. Arrow function, and then the URL, and then the text of the URL. We could think about, lining up the text at some other point, but for now we will just write it like this. So we have that. We'll drop this down the next line, and we also want to say org element property. And I'm just going to make an assumption that all links are HTTP. If we look at the messages buffer, we might be able to see what the format or the property is. Type path. Okay, path is what we're looking for. Thanks, Dukershawn. All right, so we are looking for the path in item. Now I'm going to run this one more time. Boom. All right, so that worked, and it seems to be correct. Of course, the protocol is not specified here, so maybe I'll cheat one more time. I need to support more types of protocols here, but for now I'll just add a colon and then grab, let's see, what was the other part? I want type, was it? Type. Okay, so if we put in type there, we'll run the buffer one more time. Cool. So now we have a full link here that should work in a Gemini browser. Look for the next one. Yep, that seems right. Property. Oh, thanks, Ashraz. Okay, raw link. Let's go with that instead, because I don't want to have to be in the business of figuring that out myself. So let's try that one. Great. That seems to be doing it just fine. Thanks, Ashraz. Okay, so let's see if we can actually load this up in Elfer and see if it looks more or less correct. It's not complete, obviously, but it is started at the point where it could be getting there. So Elfer, whoops, let's see. Elfer find file. Is there a way to open a local file? Major mode for Elfer. I wonder if I could just run Elfer mode in this file. Elfer mode. Nope. Doesn't look like it. What about Elfer? Is there any other mode? No. Huh. Render HTML, go current. Get start page. Render Gemini. What does that mean? For a body, it renders Gemini response body. Okay. No. Next link, download. Maybe there's no way to do this. Or what about this? Can I just give it a file path? L for go. Let's say file, home, David Will, projects, code, OX, Gemini, nope, Gemini clean slash Gemini slash introduction.gmi. No, doesn't work. Yeah, because it's not a server, so it probably doesn't figure that out correctly. Well, that is very disappointing. Let's see if I can look up the Elfer homepage. Or, in fact, come on. There is a, yeah, here we go. Local? No. Maybe I shouldn't have used / on the file path. All right, let's try it one more time. File / home, David Will, projects, code, OX, Gemini clean, Gemini introduction.gmi. Is it going to do it? Or is it going to lock up Emacs? That's always a question we have to ask ourselves whenever we're streaming here. Not doing it. Oh, wait, no, didn't do anything. Try it one more time. File / Can I do this? OX Gemini clean Gemini introduction.gmi. Yeah, it totally does not pick up on the fact that I'm trying to use a local file path. Whatever. Okay, so I think that we did a pretty good job of making some progress on that. There's other things that are still needed. We need to have a way to write the text of the link inside of the paragraph, because obviously the link text is not showing up here. And we'll have to have a way to annotate that text to refer to one of these links here. I've seen people do this a certain way. Oh, actually, maybe this is something that the browsers do. I need to look into that. But usually it's good to have a way to say that a link that's right here refers to this link in the link section after the paragraph. But that looks pretty good so far. It's looking pretty clean. That's really the main thing, is I wanted to look clean. We have our... put this back into fundamental mode. We have our verbatim and code sections. We don't have source blocks yet, but that's pretty easy because we just write out the contents of the source block with the backtick fence. And I think that's almost it. I don't think there's anything else that's really needed. Let me try looking at the... Okay, so that's that one. I'll go look at the file that we have here. And yeah, this output is terrible by comparison because they're basically using the existing ASCII backend. It's not a criticism of the author of this. It's basically just the way that they did it. I think that the ASCII backend doesn't work well to produce a nice output for gem text. And yeah, I think that's basically it. Everything else is about the same. And there's footnotes, which would be an interesting thing to add to that output, but I haven't looked into that yet. So anyway, we did make some progress, and the actual code for this is pretty small. You would have to add more code to this to support other constructs that you might be using in your org files, but the good thing is that you only have to put in what's necessary for the content that you want to export. So very easy. It's not super hard. Well, okay, I'll say it's easy from the perspective that once you know what you're doing, it's very easy to add transforms or whatever you call it. What do they call these? Anyway, these functions that transform certain elements of org mode files. Once you know how to do it, it's easy. But until then, It takes obviously 2 people to look in the documentation to figure this out. I had a lot of help from Ashraz here, so thank you, Ashraz, for helping me look all this stuff up at the same time. We might try to hack on this again in another stream, maybe next week, maybe another week, depending on what the content is next week, and get this finished up so that it could be used, because I would like to be able to use it for systemcrafters.cc, the Gemini site for that, and also for my personal site when I finally get around to setting that back up again. So it would be good to have this as a package that's out there in the world. So anyway, any questions anybody has really quickly? We're kind of over time now, but I'll answer a couple questions if anybody has anything. Someone had asked me about protocol error with EXWM. I think that there's something you need to run. Let me see here, FDD, start EXWM. I don't think I have it in this file. Let me just go look at the file directly. .files, .emacs, EXWM, whoops, EXWM, start EXWM. So I think that I had to add this line to help with this. If this is the same error that I was seeing in the past, for some reason you have to set up Xorg to allow you to access files related to your X session. That might be what it is. It might not be what it is, but if you continue to have problems with that, check out the link in the description to get to the Discord server for the System Crafters, and we might be able to help you in the chat there. So I don't really know what else it could be aside from that. Jafer says, any idea how to debug my clipboard not being shared between Sway and my native comp Emacs GTK? I don't know if there's some difference in how clipboard is handled for Wayland sessions between that and Emacs GTK. Is this PGTK? Because there is some difference there. If it's having to emulate, if it's having to use whatever it is, X Wayland or something to emulate X in the Wayland session, then there could be some problem there. But this is probably a typical issue between non-Wayland programs running in Wayland. So you may be able to find some more info on that. We can talk about it more in the Discord. You may have asked there. I just haven't had a chance to look at it yet. Oh, wow. It worked initially, then broke, and then it worked, and then broke again. Yeah, sometimes that's the way it goes, unfortunately. You don't know which way the wind is going to blow on any given day whenever you're using your own custom setup. But, you know, that's part of the fun. If you want to call it that. For some people, it's not so fun. So I understand when it's a little bit more frustrating than fun. All right, I think I've taken up enough of your time here, so let me just go ahead and thank my sponsors. Once again, I have not updated the screen in a while, so it's a little bit out of date. So if you are a newer sponsor, I apologize, your name is not here. But the people listed on the screen, at least up until the point where I updated it last, are the people who have decided to sponsor this channel, and I'm very thankful to them for doing so. It really helps me stay motivated to keep making this content whenever I know that people out there care enough to help sponsor what I do in this way. If you are interested in becoming a sponsor of the channel, definitely check out the links below in the description. I have links to GitHub sponsors and to Patreon. I also have a link to PayPal for one-time tips. And also, if you're not interested in helping in that way, definitely just sharing my videos and my channel with other people is very helpful. Any new people we get into the community is really good because we have more people joining the Discord and more people coming to these streams and sharing their knowledge and learning things. So I think it's really great to just to share the videos and whatnot. Next week, I will finally release the video that I meant to do this week, which is the efficient selection video for the Emacs Essentials series. And then after that, I'll get back to the Guix series again. I believe that's the next thing I'm going to do after that, the week after next, basically. And then next week on the stream, I'll probably try to do another .file detective since it's been a couple weeks since I did one of those. And then maybe we'll do more live coding on something. Maybe we'll do another topic. If you have suggestions for something you would like to see me do on the live stream, please feel free to leave them in the comments after the stream is over. And also you can tell me in the Discord as well if you're there. And aside from that, I think that's it. I hope everybody has a great weekend. Thanks a lot for those of you who were here live today. I really appreciate all the feedback and input. And Oslo asked, do I do a one-on-one Emacs config tutoring? I don't know. I haven't thought about it, but send me an email or ask me in Discord. We'll talk about it. Anyway, thanks a lot, folks, for being here today. I apologize that maybe it was more boring than usual today or maybe a little bit too terse, but hopefully next week will be more fun. So thanks a lot. We'll see you next time. Happy hacking. Thanks.